Let's start with binomial products. What are binomial products? Well, the hint's in the name itself. Bi, of course, means two. Nomial means terms. Polynomial, many terms. Trinomial, 3 terms. Binomial, 2 terms. So what's a binomial product? That's when we get something with 2 terms and multiply it with something with 2 terms. There we go. There's one of our basic one, x plus 6 times x plus 1. That's an example of a binomial product. Now, I don't know how you were shown it the first time. A lot of people do the FOIL method, first outside, inside last. Then there's the face method. You've seen the face method? Ha ha ha. Watch and enjoy. All right. Of course, first, x times x is x squared, but you draw in the line there. Outside, x times 1 is x. Inside, 6 times x is 6x. Last, 6 times 1, and look, creates a face. The parentheses are the ears and the nose, and then you got the smile, the chin, and the eyebrows. See, the face method. Okay. So, and tidying that up, of course, x plus 6x is, of course, 7x. So there we go. So I can't believe you've never seen that method before. All right. Then, of course, we have some special ones. I mean, the thing about maths, of course, is really sometimes described as the science of patterns. We look for patterns, because if we can find a pattern, it usually means that will create a quicker way of doing something. So if I've got a plus b squared, I don't want to go first, outside, inside, last every time, because I know every time I do this one, I get a squared plus 2ab plus b squared. So it creates a formula. We then use that formula rather than expanding out every single time. The thing with mathematicians is to discover that formula that will save us time. Sometimes we will spend hours and hours looking for these formulas to save us a minute or something like that. But the point is, it doesn't matter how long it takes us to find the formula. Once we got it, we're going to save that bit of time every single time. The a minus b squared, of course, is very similar. It's just that there's a minus sign instead of a plus sign. And the other one that you'd be used to would be the difference of 2 squares, a plus b, a minus b, sometimes known as conjugates, where one's a plus, one's a minus. Maybe you're more familiar with that with surds, the word conjugate, but it just means plus and minus being swapped around in the 2 terms. A squared minus b squared. So let's just do a couple of quick examples. X plus 2 all squared. Now I'm not suggesting that you'd actually write this line down. Hopefully we could just look at this and write it down. But of course in our head we're going, oh yes, x squared plus twice the product plus 2 squared. And then what we're really thinking is going, that's right, it came from a plus b squared. A squared is, well, that's x squared. And 2ab, well, that's 2x times 2 now. And b squared, that's 2 squared. And of course, we probably just jump straight to that line now. I would hope we're at that stage anyway. X squared plus 4x plus 4. So 3x minus 4 all squared. Yes, bang, we just write it down because we know our formula. A squared minus 2ab plus b squared. Difference of 2 squares. First one squared minus the second one squared. Here's one where it's actually a binomial times a trinomial. I find it handy actually to draw the lines again to make sure that I've remembered every pattern. But really, when I do these, still today, I'll just go, all right, I'm going to multiply everything by the a and everything by the 2. But I know I've got 2 terms in the first one, 3 terms in the other one. So if I've multiplied out correctly, I should end up with 6 things. Because each of these 3 things is going to be multiplied by the a and the 2. It's a way of keeping check to make sure have I done them all. And so, okay, I'll do a times everything. And then I'll do b times everything, collect like terms, and bingo, I've got the answer. All right, there's our first bit of theory for today.